Welcome to today's Explainer, where we're going to decode some of the universe's most mind-boggling numbers. We are tackling something that literally shapes how we understand the scale of our entire reality. From the vastness of the cosmos right down to the phone in your pocket. We're going to figure out how to make sense of numbers that are just simply too huge to handle on their own. Let's get into it.
Okay, let's dive right into this absolutely massive number straight from our source material. This endless sequence of digits represents the mass of our Earth. It starts with 5976, and then it's followed by a literal wall of 21 zeros. Just trying to write that out by hand or honestly even read it aloud is completely exhausting.
Seriously, have you ever wondered if there's a shortcut to avoid counting an endless sea of zeros just to figure out how big our planet actually is? I mean, think about it. If you drop just one single zero while writing this down, your calculation is suddenly off by a factor of 10. It's incredibly frustrating, and that brings us exactly to what we're covering today.
Here is our roadmap for today. We're going to cover the problem with giant numbers, meet the exponents, look at the magic of standard form, compare the unimaginable, and finally, check out exponents in the real world. All right, Section 1, the problem with giant numbers and why regular numbers totally fail us out in space.
As our sources point out, writing numbers like the distance from the Sun to Saturn, which is over 1.4 trillion meters, is a massive challenge. Giant numbers like that are just visually confusing. They make comparing things an absolute chore. Imagine trying to multiply or divide these massive figures. You're almost guaranteed to make a mistake just by missing a digit. This is exactly why we need a better system to simplify how we read and compare these giant numbers.
Which brings us to Section 2, meet the exponent. This is the ultimate mathematical shortcut.
Think of this as your foundational cheat code. An exponent simply tells us how many times a base number is multiplied by itself. So 10 to the power of 4, which is written as a 10 with a tiny 4 above it, just means 10 times 10 times 10 times 10, which gives you 10,000. Here, 10 is the base and 4 is the exponent. It's a short little notation that stands in for a much longer product. So the absolutely crucial takeaway here is that exponents compress repeated multiplication into a tiny, super easy to read package.
Moving right along to Section 3, the magic of standard form, or as it's often called, scientific notation made easy. Let's walk through how this actually works. Any number can be expressed as a decimal between 1.0 and 10.0 multiplied by a power of 10. Take the number 40 billion, for example. First, you place the decimal after the 4, making it 4.0. Then, you just count the digits you skipped moving to the left, which in this case is 10 zeros. That count becomes your power of 10. Boom. So 40 billion instantly becomes 4.0 times 10 to the power of 10. No more counting zeros.
And that leads us to Section 4, comparing the unimaginable, Earth versus Uranus.
Remember that giant wall of zeros for Earth's mass we looked at earlier? Well, in standard form, Earth's mass is beautifully written as 5.976 times 10 to the 24th power kilograms. Now look at Uranus, 8.68 times 10 to the 25th power kilograms. So which has the greater mass? See, we don't have to line up 20-something zeros and painstakingly match them one by one anymore. By simply looking at the exponents, 24 versus 25, we instantly know Uranus is larger, because 10 to the 25th power is a full 10 times larger than 10 to the 24th. This right here is exactly how using exponential notation simplifies comparing extremely large numbers down to a simple glance.
Finally, Section 5, exponents in the real world. From bank accounts to the computers we use every day. Because, this isn't just some classroom trick for astronomy. Look at these real-world applications. In biology, scientists use exponents to predict population growth. If a single bacterium doubles every hour, after 10 hours you don't just have 20 bacteria, you calculate 2 to the power of 10, which is a whopping 1,024 bacteria. In finance, your savings grow faster over time through compound interest, utilizing an exponential formula, so your money actually multiplies. And in earth science, the Richter scale for earthquakes relies entirely on exponents. Every whole number increase represents a 10-fold increase in amplitude, meaning a magnitude 6 earthquake is literally a full 10 times stronger than a 5.
And get this, it brilliantly illustrates how the very device you're using right now relies on exponents. Computer memory and storage sizes aren't just random. They use a base 2 binary system. A kilobyte is 2 to the power of 10 bytes. A megabyte is 2 to the power of 20. And a gigabyte is simply 2 to the power of 30. Even when we scale way up, 1 yottabyte of data is an approximation of 2 to the power of 80 bytes. Exponents are literally the foundation of digital technology.
To pull all our source material together today, I want to highlight this fantastic quote. Math is not just a subject, it is a key to unlocking how the world functions. Whether it's expressing the unimaginable distances of the Milky Way, tracking radioactive decay, or even just smoothing out the brightness adjustments on your smartphone screen, exponential math is the vital language we use to simplify and comprehend our reality.
So, as we wrap up today's explainer, I want to leave you with this thought. The next time you check your phone's battery drain, or read a headline about population growth, or see a massive number floating in an article about deep space, ask yourself, what other hidden exponential patterns are shaping the world around you? Keep your eyes open, and I promise you'll start seeing the power of exponents absolutely everywhere.